Welcome. I'm Musha, Assistant Professor, Department of Computer Science, Nehajra Women's College, Tirunelveli. Today's topic is Introduction to Stack Data Structure. The stack data structure is a very important concept in computer science. It helps to manage data storage and retrieval process efficiently. By understanding the stack data structure, we can understand the various algorithms and applications. We will go to the next slide.
Definition and purpose of a stack. A stack is a linear data structure that follows last in first out order. On the right side of the image, there is a stack of books. To get the last book, you have to take all the three books from the top. This shows the concept of last in first out principle. Also, the main purpose of a stack is to provide a systematic way of organizing and managing data on the stack by allowing only two operations, that is inserting an item onto the stack and deleting an item off the stack. Operations on stack, they are push, pop and peek. Push is nothing but an insertion. The push operation adds or insert a new item to the top of the stack. Pop is nothing but a deletion. The pop operation removes the top item from the stack. Peek is nothing but it's an operation that retrieves the top item from the stack without removing it. Implementation of a stack can be done by array and linked list. In an array-based stack, it has a straightforward implementation that can be done as single dimensional array, but it allows a constant time access to the top element. Then the limitation or challenges that can be faced by array is that it has a limited in size. It can lead to stack overflow and resizing of the operation can be computationally expensive. Now, implementation of stack using linked list. The advantage is linked list is as a dynamic allocation of memory. So that is efficient use of memory. Then the challenges is extra memory allocation for pointers and additional memory overhead will be there. Now we see the time and space complexity of stack operation. Big O of 1 for push and pop, since we at a time we are doing only one push operation or only one element is inserted and we can possibly delete only one element from the stack, so only it is big O of n, that is constant time. Then in space complexity, the overall space complexity is directly proportional to the number of elements stored in the stack. That is, when the number of elements stored may increase in size, so the space complexity will be increasing. We will see the use case and application of stack. In web browser, we are using back and forward button. The back and forward button for navigation uses stack operation. Then mainly in programming, we use function calls and recursive functions that also use stack functions. In text editors, we will be using redo and undo. But for that, stack mechanism will be using.
In the concluding part, we have just seen stack, purpose, definition, implementation and complexity.